And welcome viewers to our magnetic fields and features section. The first thing we're looking at is Earth's magnetic moment from space. So we've seen a major uptick since yesterday here, at least since yesterday afternoon, quite a bit more magnetohydrodynamic pressure surrounding planet Earth. This is Earth's magnetic moment to about 12 Earth diameters. And the scale you're seeing here is nanopascals. That is magnetohydrodynamic pressure. It's all calculated by the Space Weather Modeling Framework. If you want to read about the variables used in that, head to the Geospace Magnetosphere Movies page, click on Details. You'll find a link to the Space Weather Modeling Framework explaining what variables are used to create this model. There are a lot of variables used to create this model. Let's move on to ground magnetic perturbations. And we are expecting to see a geomagnetic storm here. We don't see the parameters yet for that. This is showing you magnetic flux density at the ground level as opposed to from space. And this will show you the most likely places for things like aurorae and induction into things like power grids, pipelines, and railroad tracks. Next, the heliospheric current sheet. Earth remains in a south pole. When there is a north pole current sheet headed this way, you can see that there in green. It's mostly on the opposite side of the sun at the moment. Keep in mind the magnetic environment can suddenly change, as we can see sunspots and things growing suddenly. So here are the GOES magnetometers, and we're seeing some sawtooth patterns in there, some spikes in the GOES magnetometers. There is some incoming plasma. There's a coronal hole wind stream eventually on the way as well. So we'll be keeping an eye on the solar wind here. Next, your line of sight ecliptic plane field plot. Going back to the heliospheric current sheet from the earthly perspective, also the solar magnetogram. Quite a bit of magnetic organization there, 3 major sunspot groups at the moment on the earthly side of the solar disk. Next, the coronal hole plot, very important for the progression of solar polar field reversals. And we see a bunch of red area there in the earthly zone. That is a highly defined south pole oriented coronal hole. A great wavelength to view that from the SDO is 193 angstroms. So there's a great view of a very well-defined coronal hole here. It is a bit south of the equator, but it does stretch up there toward sunspot 2941. And these sunspots have been underperforming. Let's take a look at the sunspots. So the likelihood of flare is still quite high here. You can see on the left pane there the solar flare probability monitor making it well over 60% there, up to 64% I think is the highest we're seeing on that. And again, I don't know why this, if this is because of the browser or because of the applet, but 3 major sunspot groups here, 2939, 2940, and 2941 are the groups to watch for significant flares. So here's 2939. Mostly stable here over the past 24 hours. It did produce some C-class intensifications. And going from west to east, here is sunspot 2940. Looks like some C-class flares came out of that as well. Or certainly some flaring. You can see a bit of a, like an arcing moment there happening. That's 1700 angstroms from the SDO. And still the most interesting sunspot group is the farther to the east and a little bit to the north sunspot 2941. So it's still the biggest group. It looks like it's experienced a little bit of degradation since yesterday as well, but it's still got quite a few opposite polarity umbrae there. It's capable of producing major flares still. There are a bunch of filaments in the earthly zone as well. Here's the full disk in that same wavelength. 1700 angstroms, if you're wondering, is part of the extreme ultraviolet light spectrum. And let's blast through some more features here for our fields and features section. So there's the X-ray flux over the past 3 days, and you can see several C-class intensifications. It looks like about 5 C-class flares, one happening once again while we did show prep. Next, the GOES proton flux, no relativistic particles of note. Just background levels there of proton flux measured at the F ionosphere layer. And looking at the real-time solar wind, we see a minor uptick here in the density. Density having made it up to not even 20 protons per cubic centimeter. Current conditions are about 10.5 protons per cubic centimeter for the solar wind density. Solar wind speed under 400 kilometers per second. So we saw this little tiny signal here. Could that have been the only coronal mass ejection strike that we'll see? Well, we'll have to wait and look. But we're expecting additional coronal mass ejecta at any moment based on the NOAA forecast. And you can see our previous video. There's also going to be a second, really a third space weather video coming out today. We've been doing 3 per day to keep the content a little bit shorter. Next in our magnetic fields and features section, KP index, a measurement of global geomagnetism here on planet Earth, is only at 2. KP2 is the current situation, not even close to the KP5 that NOAA has been forecasting. Again, expecting ejecta to arrive any moment. Next, the solar system. This is where heavenly bodies are located. Let's advance this 1 week. There's where things will be in a week. It'll be around a full moon there on the 17th. Continuing on to a star chart, if you're up before dawn, you may see Venus rising ahead of the sun. Also Mars and Mercury up there near the ecliptic, which is the yellow line that we've drawn in here at in-the-sky.org's all sky chart. The blue line is the galactic plane, if you're wondering. And let's take a look at coronal mass ejections. Nothing of note here. Here's the view from Lagrange point 1 and Lagrange point 5. So Lagrange point 1 is where our SOHO-LASCO C3 spacecraft is located. LASCO C3 coronagraph. And Lagrange 5 is where Stereo A is located. So Stereo A out here at Lagrange 5, trailing the Earth orbitally speaking. From this perspective, Earth would be orbiting in this fashion. Stereo A gets to see space weather ahead of the Earth, which is why it's called Stereo A, because it's seeing space weather happen earlier. Anyway, no CMEs to speak of. Here's me to sign off from the Smash News Network, least busted name in news. Thanks again for tuning in. Don't forget to press like and subscribe if you enjoy the content.